Hi everyone. In the given problem statement, we have to find the number of island. We are given n cross n 2D binary grid, which represents a map of 1, which is land, and 0, which is denoted by the water. We have to return the number of islands that are present. So, island is surrounded by water and is formed by connecting adjacent land horizontally or vertically. You may assume all the four edges of the grid are surrounded by water. So here, right, let us take this example. We have this grid 1, 1, 1, 0, another 1, 1, 1, 0, 1, 0, 0, and 0, 1, 1, 0, 0, 0, 0, 0, 0. This is our grid, right? And it has been told, right, all the surrounding places, right, are surrounded by water, or I can say, or everything is been 0. So what I need to do, right, I need to traverse all the elements that are present in the grid. For this, right, we can use depth first search. I can also use BFS. It's up to you how you want to do it. So now one more thing to understand, right, in how many direction I can traverse. So let's say there is one, right, I can go one row up, I can go on the left side, I can go downward, and I can go on the right. So the traversing would be DFS C plus 1 row, DFS C minus 1 row, DFS C R plus 1, DFS C R minus 1. So I am at that first row. Okay, I am going to traverse all the values. So I would be at 1. From 1, right, I can go one column here or one column down. And if I go on the left and top, right, I'd be going out of bounds. So I'm not going to do that. So I'm at 1. So I would add that 1 to that visited. And there could be, let's say, island. Okay, currently it at 0. So I'm at 1. So I would be adding this value to visited. I would come down to this one. It is also going to add it to visited. Come down, add it to visited. Below that, right, it is water. So I'm not going to traverse any further. From here, right, I can go on the right hand side, add it to visited. If I go another right or down, both of them are water, so nothing can be done. I can go up and add it to visited. I cannot go left because one is already at visited, so nothing can be done on that part. I can go again on the top, add it to visited, and I can go out here, but it's water, so nothing can be done. Similarly, this I could also add those to visited, but nothing could be added out here. Similarly, right, if I am again at 1, add it to visited. This I can add it to visited, add it to visited, add all this to visited. Okay. The number of island, right, we have got only 1 right now. Because all the surrounding island, right, I can easily traverse to them with this formula DFSC plus 1, and I can add those to visited. Now in case, right, let's say out here, if there was another one, right, I could have traversed all the other ones. It would be 0. I could add it to visited, but I'm not going to traverse any further. And this, but here, right, if I would have got 1 out here, so my number of island from 1, it would have increased to 2. But yeah, because it's 0, right, my current result will just be 1. So that's the idea, right? How can we traverse it up? Only thing out here, right, for this type of graph problem, you need to have one visited which can be of set, where you're going to keep all the unique elements that are going to get traversed, or let's say I've already looked into. The other could be the island variable. And most importantly, right, because the island is been denoted by 1 and water by 0, so you have to keep a track of it. At the same time, right, need to find the height, the maximum row height, length, and basically breadth of this grid, right? So number of rows would be, in this case, 4, and the columns, right, it is 5. So whenever I'm traversing, right, and the minimum could be 0, 0 and 0. So whenever I'd be traversing, right, I need to keep a track of that too, so that in case, right, if I'm going out of bounds, right, I can just track that up and return, so that I cannot traverse any further. So keeping all those things, you need to keep it in mind. Now, if I jump to the Python solution, right, I think the entire solution would become very, very clearer. So let me jump there. So whenever you're tackling this type of grid problem, right, so you have to find the number of rows or the max width of row. So it would be length of grid and the column, which is going to be length of grid and the first array. Once you have got that right, the second thing that we require, right, is a variable called visited to keep a track of all the values in a grid, right, that we have visited. Then also we need another thing, which is island count, which is going to be initially 0. Now I need to traverse all the elements. So for I in range 0 to number of rows, for j in range 0 to number of columns. So here, right, if I and j firstly, right, if grid of I and j needs to be 1, because if it's an island, right, then only you're going to traverse, else there is no point of it. And I and j not in visited, so in that case only you're going to traverse. So I can call the function, let's say dfs, and I'm going to pass in the value of I and j. And once that it is done, right, I'm going to increment my island count plus equal to 1, and I can return that value. Return island count. Now I need to create this dfs function. So a way of doing it, right, def dfs, we can have the value of r and c. So here, right, the first thing I'm going to check if r should be greater than or equal to 0 and r should be less than the total number of rows. At the same time, she should be greater than equal to 0 and c should be less than the width of the column, and r and c should not be in visited. And at last, grid of r and c should In case if it's 0, it should be less, right? Ideally, that should be the condition, right? Here I'm creating an exit condition. So in case, right, R value is less than 0 and it is greater than or equal to R, C is less than 0, C greater than equal to capital C, and if it's in visited and grid is 0, in that case I'm going to return because no point of executing it. Else, right, I can say visited dot add my current R and C, and here I can call the function DFS, which is going to have the R plus 1 and C, DFS R minus 1 and C, DFS R and C plus 1, DFS R and C minus 1. So if I run this right, it should work fine. Looks okay to me. There is one advertisement. Let me close that. Let me run it now. Yeah, I made one spelling error. So it would be GRID. Let me run back. Okay, I think I found the mistake, right? It is that instead of and, right, because this is going to get executed, right, only when all of them are true, right? Instead it should be or. I just messed it up. Let me just change that. And it should be also or. Let me run it now. I think it should work. As you could see, the public test case is passed. Let me submit it up. As you could see, it is getting submitted and it's getting 36.35% of submission. So the time complexity out here, right, it would be big of m cross n, or the size of the matrix or the grid. I think I can remove this value. Let me check. It should work fine, I guess. Okay, I don't think it's going to work fine because it's an or condition, right? So we need to check the value is 1 or not. Okay, it worked fine. As you could see, it's getting executed successfully. I think it is giving 41.32. It can be increased. Maybe there we can add some caching mechanism or something like that. I think if you know a better solution, which is going to get it to like close to 90 or 80%, right? Do let me know in the comments. For most people, right, the solution should be good enough. So that's all for this video. See you in the next one.